All right, everyone. So we are in our last session. I think we are doing okay on the time. So maybe let's try to also finish this session. It's about thermal testing fixture. And then before, I think this room is going to be used for HPC track. But before that, there might be a few minutes that we can also look at the signal integrity kit on back. But let's bring our attention to the presenter. Okay. Thank you.
All right, let's get started on the final presentation for the NIC 3.0 workgroup. Hi, everyone. My name is Yueming. I'm a thermal engineer from Facebook. And this section will be a joint section between Facebook, Dell, and also Broadcom to talk about the OCP NIC thermal text fixture. So we call it TTF. This is actually a standardization text procedure. And also, we'll have a live demo in the front. So anybody, if they're interested, feel free to come in the front in the end of this section, and we can talk more about it. So I actually want to break today's presentation into 3 questions. So why we are doing this, like how we actually do this, and what, as a community member, you can help us to do it better. So I will cover on the why section. I think John will cover like how we actually do this, and also Hemal together with a live demo, so to talk about how we actually make this open community work in this specific area. So actually, I want to tell a little bit story for this. Back in 2017, September, a group of us, and many of them actually sit over here, we grouped together in Dallas, and we have an OCP sub work group to talk about how we want to enable a thermal text fixture that both NIC vendor and the system vendor, we can work together very closely using a standardization methodology, and to make it easy for the NIC vendor report the thermal text data, and the system vendor can easily find, okay, what's my system cooling capability is, and whether I can take this NIC to my system without any problem, right? So the purpose is actually to provide a standardized methodology. And then you can make like apple-to-apple comparison between, let's say, NIC from vendor A and NIC from vendor B. So we can see, okay, if my system are able to take NIC A, then if the NIC B is at the same level, then I should be very easy to take this, right? So the benefits for this thermal text fixture is actually, it is very easy to adopt by both the NIC vendor and the system vendor. So actually, John just spent like 10 minutes to set up this one in front of the desk. So it's actually, once you get this text fixture ready, it's very easy, it's plug and go, and you can do your testing, use that. And also, it have a like functional text board inside, so which deliver power and also deliver, you get the power delivery together with the sensor reading directly from this text board. And also, we have 3 predefined sensor locations in this right-hand side picture. So they're actually predefined location, which means you'll get comparable data and also repeatable data from the same text fixture, even with different NIC inside. And in the end, definitely, as we just mentioned before, it will give us a very representative thermal data. So it's very easy to share. And also, using this kind of data, we can also calibrate to see, okay, when we first design our NIC card, we actually use CFD model to do this, right? So once we have the real data, we can actually see and compare whether our design makes sense, right? How comparable it is between the text data and the CFD model, and then to give us a better understanding of how we actually design the NIC in the next phase. Okay, with that, I will hand over to John to talk about more about how we actually design the text fixture.
Thank you. Okay, so what were the Yueming is given a great why we did this. how we did this was to try to, we want to be able to stress this card in an environment that is controlled. And what we're seeing with the initial data is very promising in that the goal that we set out back in 2017 of if a OCP NIC 3.0 adapter manufacturer tests using the test fixture and determines the airflow requirements, then from a system level, we know what our system is capable of and whether or not that we can cool it or not. It's something that Hemal will talk about later, in that all of that data is available before you hit aux power enable. And that means that as a system vendor, I don't have to power that card unless I can cool it and I can power it. There's many things in there that give the system vendor the ability to look at the card and say, yes, it's good. Having a standardized test fixture for thermals is one of the key elements there. So after much discussion, we narrowed in on a candlestick airflow sensor, temperature and airflow sensor. Those are all up on the wiki in different presentations. And I believe most of the companies that I've been dealing with the test fixture are using that or something very similar. We have the predefined locations. We have on the test fixtures PCIe so that you can run it to a host's computer. And we have the systems management hooked up. And so the systems management allows you to extract either through SM bus or RBT the temperature that's reported out of the NIC 3.0. Hemal will talk a little bit more about that later. The thermal team decided midway through that instead of putting a load card above the NIC 3.0, that we would use an air blocker, an air dam. And so up here you'll see samples of the board outside of the chassis, the riser cards, and the air dam. We developed 2 riser cards for the thermal test fixture. One is just a dummy, and it goes to the blocker unit, which is simply something that's 3D printed. The other one actually delivers power. If you wanted to create your own load board, you could put it in there and you'd have power. So we're trying to, again, deliver all of the features necessary for people to do this, regardless of where they are in that industry. So if you look at the setup, maybe this works. You have 7 connectors. You have 12 volt power, 12 volt ground, 3.3 volt power and ground. And then you have RJ45. Now what this does is it connects directly to the NCSI RBT from the OCP NIC. In the demo that I was planning on doing, it's what actually extracts the ASIC and optics temperatures. You can also do that through SM bus, and the SM bus is actually controlled by a microcontroller on the board, and it's connected through the USB-C connector. The last connector was the USB port that was added onto the small form factor back in about 0.73 or 0.74, and that's for smart NICs and other things. When you have everything installed with the top off, it looks like this. Of course, you can come down and play with the one here. And then one of the setups that we did hooked it up actually into a 1U, and the cable that connects the test fixture to the host system is flexible enough to where you can actually put it in a horizontal slot or a vertical slot, either one. Initial testing on the signal integrity of the test fixture, because you are extending this 12 inches, shows that this particular setup works fine for Gen 3. If you need Gen 4 to push your card to the maximum level, then you'll need a redriver card inside the system to make that signal integrity work. So right now, this is limited to PCIe. The setup that we have and that's posted is limited to PCIe 3.0. And we haven't discussed in the thermal group whether or not that we would design one of those and put those up open. They're fairly common designs. So So now Hemal's going to tell us about all the features that are in the spec for thermal management.
Thanks, John. So as John was talking about, before OCP NIC 3.0 effort even began, one of the issue I have seen or heard with the OCP Mass 2.0 and other design is, as you're getting into high-speed NICs, the temperature reporting, temperature thermal management becomes very important. And we don't have any standard way of doing it. So that was one of the big steps we took with OCP NIC 3.0. There are three different areas we focused on. First is in the spec, as we saw in the morning in Long's talk, that there are thermal tiers defined. So based on the NIC implementation, one can advertise what their thermal requirements are. We also standardize on the FRU content. So through that FRU content, one can go and discover the thermal tier that the current device needs. And this allows a system vendor to have this kind of knowledge about a given card. And when they enable that, they can know the needs of that device, as well as ability to basically meet its cooling requirement, manage its thermal envelope within that tier. And so that's the discovery and basic definition of for the card's thermal tier. In addition to that, what we did in OCP NIC 3.0, and if people read the section on management, the way it's defined, the temperature reporting at the ASIC level, optics, all of those are required. So making this as a requirement, basically, if you are going to consume more than 5 watt, then you are required to report the temperature. And the way you report this is using the standard methods. So we have the PLDM method, through which you can represent your onboard, on-chip temperature sensor, optical temperature sensor. You can allow it to be read from the BMC side, the live temperature. Also, NCSI 1.2, that's where also we are going to have temperature reporting functionality being added. So now you have standard interfaces, whether you come from RMII-based transport or MCTP, you're able to get to this kind of runtime temperature across the board, as well as the chip, as well as the optic module. And this allows one to have really standards-based thermal management. And this will really help with the system-level application, where now having this data allows one to have the policy across the system to have the CPUs, memories, devices all included as a part of the overall system thermal management. So this is really a big step, in my opinion, where we went from MES 2.0 to NIC 3.0. So I think that's one slide I have, John, if you want to wrap up.
So the thought was we would have a live demo showing the extraction of the temperatures. What works in Texas doesn't seem to work in California today. So we have a software bug, but the individual pieces are down here. Please come look. There's one kind of glaring hole in the current 0.85 version of the spec, and that is the hot aisle thermal tiers. So I wanted to give an update since Dell agreed to provide those initial tiers, and those should be coming out very soon, hopefully within the next 2 weeks, because we have the data now. We're looking at that. We're taking in more boards from different vendors, and thank you to the vendors that have provided those boards. Also data from the companies that have these test fixtures are sending that in so that we can clearly define these tiers for hot aisle. So as soon as we get that, Thomas from Intel will get that into the specification, and we'll get that released and reviewed by the group. So that's all we had on the thermal today. If you would like to come see the fixtures or anything, please come up to the front. And Rick is still in the back if you would like to look at the PCI compliance that he's brought. Thank you.